This is the lecture number 31 on irrigation pumps. So, in the last lecture, that is lecture number 30, so we were talking about irrigation wells. So, now how to extract water from the well using irrigation pumps. So, here, so we also call this as water lifting devices, because we lift water from rivers or some water which is stored underground or rainwater. Okay. So, so that is why we are, since we are lifting this water, it is called the lifting devices, water lifting devices. So, basically the broad classification here, or the water lifting devices could be like manually operated or operated by animals or electrical pumps. So, manually operated or like scoop, dome and swing basket and Archimedean screw. So, all comes under manually operated water lifting devices. So, whereas animal operated like a person wheel, the chain pump and rope and bucket. So, these are coming under animal operated. So, electrical pumps are gear pump, centrifugal pump, jet pump or mixed flow pump, and there are other pumps also available. We are going to see those. So, the basic thing here is the, as I said, the classification. So, the scoop, so one end will be tight, the other end will end of a trough will be into the water source. So, then by oscillating the trough, you get water in filling from the reservoir, and when you are keeping it down, right. So, the water will flow into the other end. So, similarly other things, the Persian wheel, it is kind of a wheel, right. So, which has buckets on top of this wheel. So, since it is a water source. So, when it moves from here to here, right. So, this bucket will carry some water, and then finally, that particular water will be thrown out at the top of the wheel, and that will be delivered to the nearest field. Okay. So, and then the gear pump, centrifugal pump. So, gear pumps are like positive displacement pumps, centrifugal pump and jet pump, they are variable displacement pumps. So, there is all whether head is discharge is varying with head or not. So, that really depends, but mostly the power we will be using in this category is electrical power, whereas other category will be using is a manual or animals. So, if you see the cost of operation, so the manual 3 to 4 times more cost than animal, the costlier than animal, whereas animal, so 10 to 12 times costlier than electrical. So, the comparatively electrical pumps are cheaper than the animal and manual. Okay. So, then so the next is so the principle of operation of all these devices. So, broadly classified here as direct lift. So, lifting water in a container, suppose you take a bucket and lift it with hand. So, that is called the direct lift. So, you are simply lifting from one place to another place. So, that is a direct lift devices. And atmospheric pressure. So, water is lifted by atmospheric pressure by creating vacuum in the chamber which sucks water up to maximum pressure of 1 atmosphere. So, here, so what happens? So, there is a pump, right, it is a delivery, suppose this is a suction. So, in atmospheric pressure case, so here the negative pressure will be created, and this is a positive pressure, right. So, that means more less than atmospheric pressure and more than atmospheric pressure. So, under these circumstances, because here suction will be created, water will be lifted up, and then the positive head. So, that will be more than I mean this will be thrown out using this. So, this atmosphere, based on the atmosphere pressure, so water will be lifted. In the third case, this is a positive displacement pump. So, here water this involves displacement of water from lower to higher level. So, just like if you have a Persian wheel or anything, so here the buckets are there. So, the water which is taken out here, so that will be lifted up and then carrying back. So, it is positively going upward, and also like a reciprocating pump. So, reciprocating pump also comes under this positive displacement the principle. So, then the other one is creating velocity head. So, at the center what happened, this velocity head, suppose you have a pump which is rotating here, right. So, high velocities which is causing at the center. So, that high velocities increasing velocity will decrease the pressure here at the center. So, then if you can connect the center to the water source, right. So, then definitely because low pressure, so it is going to suck water, and then if you have a provision of throwing this water out to the or tap water outside delivery. So, then this is a kind of a pump which works on the principle of creating velocity head. Okay. So, then using the buoyancy gas. So, buoyancy gas because it creates the bubbles. So, bubbles have less density, so that floats up, and then that kind of lifting of water from bottom to top, and then using the impulse. So, impulse force, that means the hammering force. Suppose there is a water which is flowing quiescently, right, and all of a sudden if you have a break, right, if you have a break, or if you create impulse here, so that definitely recedes, the wave recedes back, right. So, that creates the wave. So, that definitely kind of oscillations, right, oscillations. So, and that can be used to I mean displace water from one place to another place. So, the best example in this case is hydraulic ram or hydram, also hydraulic ram, okay, or also called hydram. So, which is going to work on the principle of water hammer. So, and so next is overall this irrigation water lifts are classified into indigenous water lifts. So, those indigenous in the sense manual and animal operated, and then the pumps which are electrical operated. So, here again the low head, if the head, I mean the water source is at 1.2 meter, or medium head 1.2 to 10 meter, and high head which is greater than 10 meters. So, mostly the scoop down wheel water wheel all on the low head. So, medium head case is the I mean the rope and bucket. Okay. So, and then the high head also rope and bucket, but this is animal operated, this is a long, and positive displacement pumps. So, pumps are really classified into positive and variable displacement pumps. So, positive displacement pumps are like reciprocating pump, and gear pump, right, and then what is helical pump. Okay. So, there are some other examples. So, variable displacement pumps are centrifugal pump, okay, axial flow pump, and mixed flow pump, okay, and jet pumps, etc. Okay. So, here the positive displacement pump are kind of like you displace water from one place to another place positively without losing water while transporting I mean low head to high head. Whereas, variable in this case what happens, so even if you change the head, so changing head does not influence the discharge. So, discharge is almost constant, right, even if you change the head, discharge is constant here, whereas variable displacement pump. So, discharge will vary inversely with the head, right. So, if you increase the head, so discharge is going to decrease. Okay. So, we are going to see these positive displacement pumps and variable displacement pumps in the following sections. So, the basically, as I said, the pump is a mechanical appliance, okay. So, used to increase the pressure energy of liquid in order to lift it from lower to higher level. So, this is the main definition of a pump. So, pump basically used to increase the pressure energy, so that you can lift water from low head to high head. So, basically it creates the low pressure at the inlet and high pressure at the outlet end of the pump. So, that creates suction at the lower end, and at the delivery head the pressure head will increase. And the principle of working pump is distinctly different from the indigenous water lifts, okay. So, in which water is lifted by displacing through buckets, water wheels or screws. So, whereas and also it does not require electricity. So, whereas the other pumps, electrical pumps, so that requires electrical energy. And two basic groups, as I said, the positive displacement pumps and variable displacement pumps. So, you are going to see how they are different. So, in case of positive displacement pump, the fluid is physically displayed by mechanical devices like a piston, gears and cams. So, these are mechanical devices which will help in displacing water from one place to another place. So, the volume of water delivered is constant, as I said. So, even if you take lower heads, the discharge is constant because it's a positive displacement, and also it works on the piston, right, the rotational of a particular device which displaces this, okay, regardless of the head against which it operates. The volume of water delivered varies with the speed of the piston. So, basically it does not depend on the volume of water, does not depend on the head, but it depends on how fastly the piston is moving inside. So, or number of strokes it is making, okay. And contains large number of moving parts required rather than attention and maintenance. So, since it has a lot of moving parts, it requires frequent maintenance. So, whereas variable displacement pump, the discharge varies inversely at the pressure head. So, in this graph, this is the discharge on y axis and suction head and x axis for positive displacement pump. So, if you see the head, as head increases, so the discharge is not influencing much up to certain point or certain head, then after that still the discharge is going to decrease, okay. So, this is basically due to the atmospheric pressure. So, all these pumps are going to work on the principle of on works on the suction, which is lower than atmospheric pressure. So, if you see, so generally what one atmosphere is about 10 meters, right. So, 10 meter equivalent water height. So, but in practice that is a theoretical, but in practically if you take the losses into consideration. So, you may get like 7.5 or something like that. So, up to that the discharge may be constant, then after that what happened, the atmospheric pressure definitely influences the suction, okay. So, that is the reason. So, the discharge is no more constant after 7.5 meters, something like that. So, next is the positive displacement pumps are broadly classified into reciprocating pump, rotary pump, gear pump, helical rotor pump and diaphragm pumps. So, again reciprocating pump, so mostly it is the to and fro motion based. So, the lift pump and force pump, okay. The lift pump, again the shallow well pump and deep well pump, the single acting, the plunger type, and the double acting plunger type, deep well, because in order to increase the discharge from the deeper I mean deeper distances, then you need to use the double acting. So that, and similarly force pump has shallow water pump and deep well pump, it is a single acting shallow, whereas deep has two single acting as well as double acting case. So, we are going to see what is single acting and double acting, we are going to discuss that, and we are going to discuss I mean most of these pumps we are enlisted here. So, here if you see this, the reciprocating pump. Okay, so, the reciprocating pump here basically it consists of a piston and plunger, right. You see this picture, right, clearly. So, reciprocal is a to and fro motion, right. It has two valves, one at the bottom, then other at the top. Okay. If you see here, this is a valve number 1 and valve number 2, and this is a cylinder, right, the piston, right, so the crank. So, what it does, so it is going to turn, so the piston is going to move, oscillates like to and fro motion. Then when it moves this direction, right, it creates suction here, right, so that this will lift up, right. So, the suction basically pulls this top valve down, right, it opens up and it downs. So, that the water will enter through this chamber, you stay here. Then when it moves this direction, it pushes the fluid into this and helps in sitting this valve in the ports. Then this valve will be opens up, and then finally water will be coming out. So, this is the to and fro. So, remember, so for one, I mean for one stroke it takes water, then another stroke it releases water. Okay. So, that is why this is, so in double, for 2 strokes it gives 1 discharge. Okay. For 2 strokes it gives 1 discharge. So, again you can see this how it is happening. So, while taking out it is opening, and so for 2 strokes, so 1 discharge. Similarly here. Okay. So, it basically consists of it is either plunger working in closed fitting cylinder, a movement of piston displaces the water in the cylinder. It could be a lift pump and force pumps. Okay. So, reciprocating pump here could be, as I said, lift pump and force pump. So, the lift pumps, it will be designed to pump water from the source to the level of the pump spout only. So, up to this, so the water is I mean if you can do this to and fro motion kind of thing. So, water will reach up to this point, right, and it will be used for shallow waters, right, and the same thing here exactly here there is a valve. So, there is a valve here. So, there is a valve here, okay, the 2 valves. So, what happens if it goes down, so this valve will be opens up, right, this valve will opens up, and whatever water which is present here, this will escape, right. So, when it takes up, right, so then so this valve will be opens, the water will be enters, and this will be closed. Okay. So, then all water will be staying here. So, like up and down motion. So, the water one for 2 strokes 1 discharge. So, here the main discharge difference between lift pump and force pump is this will be used for shallow and this will be used for deeper waters, whereas the pump unit which is staying inside the water source. And so, in the reciprocating pump, so if you observe the theory behind this, so the area swept by the piston, area is equal to pi by 4 d square. So, that is area of cross section, right. So, area of cross sections, if this is the d, okay. So, area swept by the piston is, So, this is pi by 4 d square, and volume swept is, suppose this is L, the piston length. So, that is volume swept. So, this much volume for each stroke, this much volume will be carried up, right. So, A into L, and volume of efficiency. So, that depends on, I mean, how efficient is this theoretical volume and actual volume. So, the actual volume is, if this is Q. So, if based on the the efficiency of the theoretical volume, you get actual volume, and then pump discharge is equal to Q into this P, the swept volume, multiplied with number of strokes, you get the total discharge. Okay. And then the slippage is, that is basically causing the difference between actual and theoretical volumes. So, the slippage is denoted with the theoretical volume minus actual volume. So, that the difference will give the slippage. And then the other thing is the force required by reciprocating pump. So, the force required by a reciprocating pump to lift the piston. So, the basically, in order to lift water, suppose this is the piston, right, this is the cylinder, and in order to lift water, suppose this is the water, in order to lift water from here to here. So, from here, this point to this point. So, it has to experience, you know, the weight of the water, that is weight of the water, and then weight of the piston, the weight of the piston rod. So, these three weights we have to calculate, that is that much force we have to use here in order to lift. So, the weight of the piston, weight of the pump rod, and weight of the column of water. So, these three things we have to add it up, and that will be equal to the total force applied on the piston in order to lift water. So, if area A is the small a is the area of cylinder, L is the length, H is the total height through which water is raised, and P the force required to lift the piston, okay, and W specific weight of water, and weight of water raised in one stroke is equal to W A into L. So, A into L is the swept volume, and if you can multiply with the density or specific gravity. So, you get 1000 into A L, where W is equal to kg per meter cube. So, that is 1000 into A L is the weight. So, this is a kg force, this is kg force we say. So, then work done in one stroke. So, work done is force multiplied by the distance, that will give the our F into S we call. So, the distance here is the h, small h. So, through which you can lift water. So, that is the distance you have to, the force needs to be applied to take that weight up to the distance h. So, that will be, that is equal to P h. So, P is equal to 1000 to A L is the force or the force required to lift water. This is the work done anyway. The P is independent of the diameters of the suction and delivery pipes if friction is neglected. If no friction, then this is definitely independent of the diameter and suction of delivery pipes. So, and so next is the single acting reciprocating pump. So, here if you see in the single acting, so one discharge, one discharge will happen with two strokes. So, remember that. So, if you clearly see this picture, right. So, for see look at this. So, the two strokes will give one discharge. So, there is always some intermittent gap, it is not continuous flow. Okay. So, that means two strokes will give one discharge, and in the down there is a picture. So, that will really help us in getting the discharge continuously. If you have like a air chamber, so nearby the discharge point, what happens in one stroke. So, when this lifted up, the water will be entered through this, right, this will be stored, and this compresses down, right. So, this compresses down, that will help in flowing the water, and even during one stroke. Okay. So, this will help in getting water continuously in case of single acting reciprocating pump. So, so during suction, if you see here, during suction stroke, the pressure of the air in the vessel maintains in the flow water through the delivery pipe. So, that I just explained. So, next is and whereas in double acting reciprocating pump. So, here what happens, if you see, so there is, this is the chamber, this is the whole thing is a chamber, right, this is the whole thing a chamber, and this is the suction and this is the delivery and this is suction. Okay. And here look at this, so the center there is a piston, right. So, the piston goes to and fro motion. Okay. So, and then suppose the piston is taking like this is called, we call outstroke. So, when outstroke, so this piston is going to move up to this point and creating suction here, right, at this point, and water will enter through this, right. At the same time, if you see the diagonal points or acts the same way. Okay. So, here this opens, this is going to open up. So, then due to this, so what is going to deliver here? At the same time, these two diagonals will do opposite. If these two opens up, this closes up. So, when this closes up, so in one stroke, when this goes in stroke, right, and the diagonal the diagonal walls closes or opens accordingly. So, in one stroke, in each stroke you get a discharge point, not like in case of single acting case. So, there you can see what you call a video here. Wait a minute. So, the video can be shown in case of single acting. So, anyway, so it is not working, but that is okay. So, single acting double acting case, you get one discharge for one stroke. Okay. So, here there is an example. So, the single acting reciprocating pump has a piston diameter and a stroke length. So, the piston makes 40 double strokes per minute. So, the suction and delivery heads are 5 meter and 10 meter respectively. So, find the discharge capacity of the pump and the force required to work the piston during the suction and delivery strokes. If the efficiency of the suction delivery stroke 50 and 60% respectively, the HP required of the pump in operation. So, there are so this is a single acting pump, right. So, 10 centimeter is the diameter and then 20 centimeter is the stroke, I mean the stroke is 20 centimeter, 10 centimeter is the piston. So, once we know that 2 strokes will give 1 discharge point, but before that the area of the piston pi by 4 d square. So, putting the values you get this area of piston and the volume of swept multiplying with the length, you get the swept volume per stroke. Then the pump discharge is equal to, so we know the RPM, that is a 40, right. So, 40. So, clearly it is mentioned 40 double strokes, that means one double stroke will leads to one discharge point, and so that the discharge multiplied by number of double strokes in a minute. So, that will give the discharge of the pump. So, that is 64 LPM. Then average pump average force in the suction. So, that is equal to, you put the equation A area, suction head and specific weight, right. So, specific weight of water. So, suction head area and suction and the efficiency of the stroke. So, here so this is swept volume, right, and multiplied by swept this is the swept volume swept by a piston per stroke, but the area into suction head. So, this is area, right. So, area and suction head we will give the total volume. So, suction head here is given the 5 meter, like 5 meter, and the specific weight of water is 1000, and then efficiency during suction is 50%. So, that will give the 80 kg force, right, during suction. So, here the 5, so instead of L, so we took 5, right. So, we took the total, So, this is the piston, but instead of taking 20 centimeter, we took 5 meter. This is a suction, right. So, why we took 5 meter? Because the force in order to take water from this point, even if it is 20 liter or 20 centimeter of that volume. So, you need to transport this water all the way through, right, all the way through. So, then only you get water here. Even a small disturbance, small volume of water, unit of water must be taken from here. Okay. So, so this is a continuous, this is a continuum actually. So, let us so here average force is done. Then after that, average force in delivery, similar to the suction delivery also you calculate, you get this, and horsepower required, the total force suction plus delivery into distance moved divided by 4, 5, 6, there is a standard formula. So, then finally, you get 0.374 is the pump HP. Okay. And then so next is the similar kind of example, but in case of double acting, this is the double acting reciprocating pump, has a piston 20 centimeter diameter and 5 centimeter diameter, 20 centimeter piston rod 5 centimeter. Okay. If you remember this, okay, so this in case of double acting, so there is a the piston in between, right. So, the piston in between, sorry, yeah. Okay. So, suppose you have this, so let us see this, okay, and then you have piston in between, right. Good. So, here one wall, there is another wall, there is another wall, there is another wall. So, there are 4 walls around here, and this is the piston. Okay. So, this is the piston rod, this is the piston rod, and this is the piston cylinder, right. This is the cylinder and this is the piston. Okay. And then there is valves. So, this is suction, this is delivery. So, in this case, the length of the piston stroke is 30 centimeter, and the speed of the crank moving the piston is 50 rpm. The suction and discharge heads are 5 meter and 10 meter respectively. Determine the discharge capacity of the pump and the HP required to operate the pump. So, remember here the one stroke leads to one discharge, right. So, then first thing is the cross section area of the piston area. So, use the pi by 4 d square and you get this, and the cross section area of the piston rod is equal to the piston diameter is, rod diameter is given, and that is this, and the force required to work the piston during outstroke. So, outstroke in the sense, so we are taking the piston, so this side, this is outstroke. In that case, the for suction, so for suction what happened? So, if you take to the outstroke, so that means this is going to close and this is going to open because of the suction, right. So, suction, so definitely the for suction force is area, right. This is the swept area, and then suction head, the suction head is specific weight of water. So, that will give to 155 kg during the suction, right. And similarly for delivery, so for delivery what happened, the delivery means the other chamber, so other side. So, you have this piston, right, you have a piston. So, this side you have the suction, the other side you have discharge. So, when you are talking about delivery or discharge, you have to subtract the volume of the area of the pistons or volume occupied by the piston rod. So, that is the A by A minus 1 delivery head and specific weight of water. So, that will give this much, and total force during outstroke is suction and delivery, you get the total here, and the force required to work piston during in stroke. So, similarly the opposite. So, in stroke what happened, so that means going this side, right. So, when you when piston is moving this side, right, this side, so suction will be created here, delivery will be created here, right. So, suction, if this chamber is suction and you have to subtract area of the rod here. So, the area of the rod, suction head and specific weight of water, this much. And delivery, so delivery you need not, because delivery is happening here in this chamber, and that is simple area of cross section of the piston, suction head and the specific weight of water. Okay. And then that leads to your 310 kg, okay. And the total force during in stroke, so that will be the sum of these two, and discharge during in stroke will be A into L into RPM, right. So, that will be A into 30 by 100 into 50, which will be 465 liter per minute. Okay. This is discharge during in stroke. Okay. Total force during outstroke is calculated, and total discharge during in stroke is calculated. Okay. And then similarly total discharge during outstroke needs to be calculated. So, that is the total discharge during outstrokes, that is A minus A minus 1 area into L into RPM. So, that will give your discharge outstrokes, and then total quantity will be discharge during in stroke and discharge during outstroke. So, that will be 900 liter per minute, and horsepower, the total force, that is the maximum force into distance moved. So, here the total force is 455.2, that is maximum of these two, into distance moved, that is 30, okay, divided by 100, and 50 into L, 50 into 2, because the distance moved is 2 double strokes, right. So, 50 into 2, and which will be 2.99, and that equal to 3 HP. Okay. So, this way we have to solve this problem. And then the other pumps are like rotary pump. So, rotary pump works on the principle of, here there is rotors, two you can see the cams we call. So, the cams are rotating. So, one is a drive cam, the other one is like a slave. So, the drive will help the slave, and then after that what happened, it really transport water by pushing the fluid into the gap between the or every time the fixed amount of water is being transmitted from one end to the other end. So, similarly here this picture will show the same thing. If you see this picture, so initially water enters through this is a cam kind of thing. Then after that because of this motion, so this fluid will enter through the next chamber, then finally through the outlet. Okay. So, and the next is the gear type. So, gear type also similar to the cam type, gears also work in the similar principle. So, this basically used in the shallow sumps, or maybe if you see the kerosene, pumping kerosene, pumping oil. So, these gear pumps are being used. And the helical pump, in case of helical pump, the main mechanism here is the rotor, and then a rubber helical rotor, and there is a rubber starter. Okay. The rubber starter, it's kind of it creates the cavities when it rotates. So, when this rotates, because this is kind of the helical rod. So, when this rotates on a rubberized surface, so this is definitely sometimes pushing and pulling, pulling, right. So, it pushes the rubber and at the same time pulling. So, that creates the vacuum, and the vacuum will help in pushing the water inside. So, sometimes this is called cavity pump, because it creates the cavities in the rubber starter. And the diaphragm pump, mostly this is used for in case of pumping muddy waters or slurries, those kind of things. if you see this, so it contains two diaphragms, one other end. So when one end goes in, the other end pushes the outside. So similar to your double acting reciprocating pump, it works. So for each stroke, there is a discharge point. If you observe this, so the two diaphragms, one at this is one diaphragm, this is another diaphragm. So it goes like to and fro motions, right. So then it pushes means it creates suction here. So when it goes here, creates suction. When it comes here, this creates suction here, right, and the same thing delivery, right. Okay. So this is all about the water lifting devices, or basically we focus mostly on reciprocating pumps. So reciprocating pumps are the pumps which positively our positive displacement pump positively takes or displaces water from low head to higher head. Mostly these are the plunger pumps, or you can the piston pump or gear pump. So those kind of things. So again, this is basically in two parts, single acting and double acting. Single acting, two strokes will give one discharge, whereas double acting, one stroke will give one discharge, and we solved two problems here for in case of single acting and double acting. And other pumps also we have seen the working like diaphragm pump. So two diaphragms, what's the diaphragm in the kind of this rubber, the sheet. So rubber sheet will create, the flexibility will create the suction, and then that will really help in pulling the water. And then the other ones are like a cam type of pumps, and also the vane type pumps and gear type of pumps. So these pumps are mostly used in shallow waters, mostly for irrigation purpose. Diaphragm pump is used in paddy watering paddy fields and other things. Okay, thank you so much.